So when we have multiple indexes here, MongoDB has to decide a winning plan that would be the best approach, that the index that it will take that would give the best performance. So it stores that approach in a cache memory so that it can be used again. So it stores that as long as the index is recreated or new indexes are added or removed, or when the MongoDB server is restarted. So when those things happen, it is removed. It is not stored anymore in the cache memory, but till then it can be used from that memory. And then we have a new index called text index. So when we had text data in the document, we had regex operator, but that was not a high performance. That doesn't give the best performance. So we have something called a text index, which divides a text into multiple uh, elements. Also, this will remove these stop words like is and a. So this will take the most important words in the text and take them as single elements. So we can, when we have to search uh, from the text by using certain elements, certain words, that it can be easily done with by using text index. So we create a new collection here and insert title and description of products. So we have this text descriptions here and text title. So here we create an index on description. So this will not work as a text index. This is just the normal index that we were using before. For text index, we have to render the description as text. So then we can search in the text by using this text operator in find, and then we write this search operator. For example, the word awesome. So when we run this query, we get both the documents here because both of those had the word awesome in the description for which we created the text index. And then if we have like book, this word is only in one of these documents, so we get that only. Example, if we write this red book, so one of the word is in one document description and other word is in the description of other documents. Still we get both of these together because this will search for both these words in all the documents and it will give both. So if we want to put them together, we want it to be considered together, so then we will have to use this double quotation again with a backslash. So red book does not contain, it doesn't, it's not present in any of the single document. So for example, we have this autumn book, we get this particular document here. And if we just had it without the extra double quotation and backslash, this will give both the documents. Now here we have this score. So MongoDB will give a score to both the documents here. When we search for these two words, when we search for this, if it is present, if they're present in both the documents, so MongoDB will assign a score to the result that we get to both of them and sort them like this. We write this score and we get this metadata, and we use this meta operator to get this metadata. So this score is sorted here. So this score tells which is given more important. For example, here we have this both of these words in this document, and this document has only one of these words, so this will get more score and it is considered more important while fetching. So MongoDB does not support multiple text indexes in one collection. That will be a very low performance, that will take a lot of space, because we can have huge text documents, we can have huge text data in those documents, so that will not be good. So here we cannot create another, we just want to create another index, a text index, for example on title, so this will not be created separately, that will give an error. But we can do this, we can create an index for multiple fields here. So for example, we create this index for both title and description and put text. And here, for example, we insert a new document here. So here we can see that we can also search for text in the title, because car text is only in the title here. So we this created this on title and description both. So this works here. And here by using this get indexes, we see that we see the name of the index here, and one is ID, which is by default. We see the default language is English here. So we will see that we can also change this language. We can specify the language that is supported by MongoDB that we can put here. But English is the default language here. So here we can add more fields here. For example, this default language English. Here, if we want to specify another language like German, uh, so then the vocabulary, the language will change. So which stop words to remove, it will decide based on that language. That will also change, because it only takes the most important words that are needed, and then we can have these weights. So this we can specify which of these fields should be given more importance in the weight. For example, we put title as 1 and description as 10. So we are telling here that description should be given more importance in the result. Uh, so the score of description will be more here. We have these products here, and then if we search, for example, for this word red, and then we put text score here. We want to see the result. We see this score. So this will be different if we just do it without putting the weight, without specifying this. So here, if the word is in description, that would be given more importance here and that would have more score. Now we have something called geospatial uh, data. So this is the spatial geospatial data. We can run the queries for geospatial queries like we had all other queries. We can run the queries for locations. For example, if we want to see all the restaurants near us when we are in a certain location, we can use these queries. Here we have certain queries for geospatial data. For example, we create a new collection here, a new database, and from Google Maps we use this location. So this is the format that we have to write geospatial queries. First we give the name inside of a document, then we give the location, and there are two fields here, type and coordinates. Type can be point, polygon, etc. So it can be different types of different types of field. And then the coordinates, we have this longitudinal coordinate and latitudinal coordinate. So these we have to specify exactly. We can use Google Maps and get these exact coordinates of a particular location. So inside there is a place called Golden Gate Parks in USA. So inside of that, this is a particular building. So we give this. So we have name and location with type and coordinates here. So now, for example, if we want to find, we give a point with coordinates this different coordinates, and then we want to see if that point is near this California Academy of Sciences that we inserted in our collection. So this is giving an error because we have to create an index to run this particular query. We have no index right now. So this unable to find index for geo near query. For geospatial data, we have certain queries that we have to use here. So we create an index here. In index, we put the index on location because we want to see if the point is near that particular location. So this 2D sphere is what we have to write, not one or two here. For geospatial data, we have to write this. And then if we try to find that particular point, we get this. So that is near. Now we will have to specify maximum and minimum distance to see if a particular point is near this location or not. How near we want it to be, we have to specify that. So on Google Maps, we see that that particular point was somewhere between 400 and 500 meters. So we have these operators, max distance and min distance are in meters. So for example, if we write 410, this will not give any result because that point is not under maximum distance of 400 meters. So then we put 500 here, it will give this location that we inserted before. So this can be used in multiple applications if we want to see if one point is near to another point. Now we can use that in multiple applications. For example, if we want to see all the points that are inside a particular location. So in Golden Gate Park, we have these three more location. We add these three more location, and two of them is inside it, and one is outside of that area. And then will see we will run the query to see which of these points are inside that location. So we give this location and coordinates from Google Maps. We'll see them and put them here. So we have these four places, and then we assign certain variable to all four of them for their coordinates. And then if we run this query on location, we use this geo within operator. So this operator will tell us if a point is within an area. And then we have the geometry operator to define the geometry, and then we will have this document again type and coordinates. So this type will be polygon. So we want to see if the points are enclosed in this area, it will have to be a polygon. So around that Golden Gate Park, we choose 4 points and get coordinates. So these were the coordinates that we put here for 4 points on 4 corners of the Golden Gate Park to see. Then we put the variables here. We see we get only of the three of the places out of four that we had, because one of them was outside in the area of the polygon. So this is all you can see how many places are inside a particular location, a particular area, by using the coordinates. So it is called geospatial data.